So this video you're about to watch is going to be talking about particles. Okay, I don't want you to get all freaked out about the word particle. Okay, all it is something that moves left and right. Okay, so you may think of it as a bug moving left and right on a table. You may think of it as a fighter jet that only can go left and right. You may think of it as, I don't know, anything that just moves left and right. And we're going to talk about, its position as it's moving left and right, like on a number line. We're going to talk about how fast it moves. We're going to talk about it accelerating. Sometimes it's going faster, right? So if you hear or see the word particle, just imagine whatever object you just right now envisioned in your head moving left and right. All right, here we go. Okay, so the first thing I want you to notice is when we are talking about position of whatever our particle is, that we tend to use S of t or x of t, all right? And displacement is how much it moves from one location to another, okay? So you start at one time, you measure to a second time, and you can figure out the displacement, okay? Now, there are different units that are used for displacement, right? Sometimes it's meters, maybe it's feet, maybe it's yards, maybe it's inches, maybe it's miles, okay? It's a distance, it's a displacement, okay? Now, there is a difference, however, between distance versus displacement, okay? So let me say that I start here and I end here. From a straight line, from here to here, that's displacement. Okay, displacement. That's how far I've gone from where I started to where I ended. But the route that I take, right? Maybe this is the way that I went. I did this and I went all around over here and I ended up here. That is the distance that I travel, which is, again, it is different. Okay, next, let's talk about velocity. So velocity is going to be represented with v of t, okay? And velocity is just the first derivative of the position function, okay? And the units are meters per second, for example. Maybe it's feet per minute. Maybe it's miles per hour. Okay, so it's a certain unit of distance over a certain amount of time. That's what you're seeing here. Displacement over time. All right, now, there are some questions down here about velocity. Okay, a positive velocity means that a particle is moving to the right. Okay, so like on my little introduction thing, when we're talking about this particle that's moving, it's on a number line and it can only go left and right. So if you have a positive velocity, it's moving to the right. And a negative velocity means you're moving to the left. Okay, the particle is at rest when velocity is 0. Okay, and speed is the absolute value of velocity. Okay, so it doesn't have direction. Okay, so there's no negative speeds. Okay, only negative velocities. All right, next, let's talk about acceleration. Okay, and again, a lot of notation here. Okay, so acceleration is represented by the letter A, and it is the first derivative of velocity or the second derivative of position. Okay, and the units here are, and again, these are just some examples. Let's say meters per second squared, which can also be written as meters per second per second. For those of you in IB, you may see it as meters second negative 2, which is going to put it into the denominator. Okay, so you could also see something like feet per hour, per hour. Okay, it's a change of velocity over time. Okay, now a positive acceleration means that the particle is increasing velocity. Okay, and think about that, right? Let's say you're driving on the freeway and you're going 55 miles per hour without changing. The second that you put your foot on the gas and you start to increase your velocity, that means you're accelerating. And a negative acceleration means that you are decreasing velocity. Okay, so let's see if we can get some of these questions answered here. So speeding up means that velocity and acceleration are the same sign. Okay, so again, let's think about this as a number line. Here's my number line. Okay, and I have a particle that has a positive velocity and a positive acceleration. That means we are speeding up. Okay, likewise, if this is my number line and I have a negative velocity and a negative acceleration, then my particle is going to start going faster. It's speeding up versus slowing down, which would be opposite signs. So here's my number line. Here's my particle that has a positive velocity but a negative acceleration. It's gonna slow down. And it works the other direction as well. If my velocity is negative but my acceleration is positive, it's gonna slow down. Okay, so let's see if we can put all of this together on example number 1. All right, so as I'm reading, let me see if I can highlight and get some stuff that's important. A particle moves along a line with position at any time t greater than 0, which makes sense, right? You can't have a negative time. We're not going back in time. And this is a position function, okay? That means if I know exactly what time I'm talking about, I can tell you exactly where we are on the number line. For example, at t equals 0, if I put 0 into that function, I get 30. Meaning at 0 seconds, this particle, right? I'm going to think of it as a bug crawling along the number line. This bug is sitting at 30 meters. Okay, so just envision a number line. And at that particular time, that's where the bug is. Okay, so for question A, when it says find the displacement of the particle or the bug during the first 2 seconds, well, I need to know where is the bug initially. I just did that. And where is the bug at 2 seconds? So if I put 2 into that function, I get 8 minus 36 plus 30, I get 2. Okay, so think about this. I'm going to draw what happened here. The bug was here at t equals 0, and the bug ended up here at t equals 2. So the displacement is negative 28 meters. Okay, the sign matters. This is where it started. This is where it ended up. It's negative 28 meters. Okay, so now the average velocity of the particle, okay, and again, velocity is a change of distance over time, right? So we just said in the first 2 seconds that this bug went negative 28 meters, and we're talking about 2 seconds, which reduces to negative 14 meters per second. Okay, so for part C, we want the velocity. Okay, notice the difference. Let me make sure I highlight this for you. Question B asks for average velocity, but the next question is asking for just velocity. That means instantaneous velocity, which is the derivative. Let me write this down. Velocity is the derivative of the original function, which is, in this case, 3t squared minus 18t. Okay, now if you're wondering where am I getting this from, I'm looking right here. I'm looking at the original function and I'm taking the derivative. Okay, now I'm finishing to answer this question. It says we want this at t equals 2. So I'm finding the velocity at 2, which is the same thing as the first derivative at 2. 3 times 4 minus 18 times 2 equals negative 24 meters per second. Okay, now when you answer these, you want to make sure that not only do we have units here, but this is when t equals 2. All right, when is the particle at rest? Okay, if you look back at the notes that we just did a second or two ago, we know that when velocity equals 0, that's when the particle is at rest. So I've got v of t. I just figured it out in the previous problem. It's right here. Okay, so let's set that equal to 0. 3t squared minus 18t equals 0. I can factor out a 3t, and I figure out that this actually happens twice. It happens when t equals 0, and it happens when t is equal to 6. Okay, at the very, very beginning, before the bug ever moves, its velocity is 0. And then 6 seconds later, its velocity is 0 again. That's when the bug is at rest. Okay, so now it's asking what is the acceleration of the particle each time it's at rest. Keep in mind, we just figured out it's at rest at these 2 times. Okay, so let's figure out what acceleration is. Acceleration is the first derivative of velocity or the second derivative of position. So I'm looking at the velocity function. It's highlighted in purple at the top of the screen, and I'm doing the derivative of that. 6t minus 18. Okay, so let's figure out what the acceleration is at 0 and at 6. All right, so when I put 0 into this function, I get 6 times 0 minus 18, which is negative 18 meters per second squared. And when I put 6 in there, I get positive 18 meters per second squared. Okay, so again, you might want to just sort of be very clear. This occurs when t equals 0, and this occurs when t equals 6. Okay, now this question is unbelievably important. F, all right? Question F. When is it speeding up and slowing down? You're going to see questions like this all the time. Like, I can't even begin to express how important this is. So what you want to do is set up a number line. Okay, and you want to compare when the velocity equals 0, when the acceleration equals 0. Okay, which you have done in previous problems. So I'm going to set up this number line. Okay, here we go. Number line. I'm going to put velocity up top. And acceleration down below. Okay, and I know my number line starts at 0 because we don't have any negative times. From question D, I know that at time equals 6 that my velocity is 0, right? So we figured out that velocity was 0 because this equaled 0 at 6. Okay, I also need to figure out where my acceleration equals 0. So if this is the acceleration function, that equals 0 at 3. Okay, so now what I want to do is I want to compare what is happening to velocity and acceleration in each of those time intervals. I'm going to add some dotted lines. So I want to know what's happening between 0 to 3, from 3 to 6, and from 6 on. Okay, so I'm just going to plug a number in that's in that interval. I don't care what the actual number, like what the result is. I only care if it's positive or negative. Okay, so a number in, let me highlight, a number in this interval could be like 1 or 2 or 2.5. I just need a number to plug in there. I'm going to plug in 1. So when I plug 1 into this velocity function, I get negative. 3 times 1 is 3. 1 minus 6 is negative 5. I multiply those together, I get negative. And when I take that exact same 1 and plug it here into the acceleration function, I also get negative. Okay, what that tells me is that in this time interval, since those signs are the same, the particle is speeding up. I'm going to write that down. Speeding up from 0 to 3. Okay, let's look at the next time interval from 3 to 6. So in here, I'm going to pick, 4. I'm going to plug it into the velocity function and get negative. I'm going to plug it into the acceleration function and get positive. That means the particle is slowing down. Slowing down from 3 to 6. And then from 6 on, let's plug some number in there. You can pick any number you want. I think I'm going to pick 7. When I put 7 into the velocity function, I get positive. And when I put 7 into the acceleration function, I also get positive. So the particle is now speeding up again. Speeding up from 6 on. All right. Okay, now I'm going to continue to look at that number line because it tells me so much information. All right, so when this is asking me to describe the motion of the particle along the horizontal line, this will let me know when it's moving left and right. Okay, so I can say from 0 to 6, the particle is moving left because it's negative. And from 6 on, particle is moving to the right. I'm only looking at the signs at the top of that number line. Okay, so then this last question is talking about the position of the particle. Okay, position. Now we just said the particle moves to the left, then it turns around and it moves to the right. That means for this question H, I want to know where it started, how far did it go to the left, and then it turns around and goes to the right. This is all happening in the original S function. I know that at S of 0, it started out at this position of 30. This happens at 6 seconds. So where is the particle at 6 seconds? Well, if I put 6 into the original function, I get negative 78. And then it turns around. So we're going to say starts at 30 meters when t equals 0, moves left to negative 78 meters at t equals 6, then moves right. Okay, now if you really, really want to make me happy, I would suggest pausing the video and trying these 9 questions on your own and then unpausing to see if you got them right. Okay, but in the meantime, I'm going to do them. Okay, so we're looking at this graph. This axis right down here is all about the minutes. This axis over here is about velocity. Okay, so let's see if we can answer these questions. What is the velocity at 20 minutes? Well, 20 minutes is here, and I can read that to be 40 meters, meters per minute. The velocity at 40 minutes, that's this point. I'm reading it down here. It is negative 40 meters per minute. Okay. If it's asking when is the velocity positive, that's above the x-axis. That would be all of that area. So that happens between 0 and 30 minutes. Okay, and then if it wants to know when the velocity is negative, that's under the x-axis, which happens from 30 to 55 minutes. All right, next we have the velocity being 0 here, here, and here. So to answer this, I'm going to be putting 0 minutes, 30 minutes, and 55 minutes. Okay, now this one, when it's asking what the slope of the graph represents, keep in mind that's the change of y over the change of x. Up here, we've got velocity. So that's meters per minute. And the change of x is more minutes. So it's the change of meters per minute per minute. That's acceleration. Okay? Whenever you're stuck on what it represents, look at units. Okay, so if it's asking what's the acceleration at 25 minutes, that means let's see if I can get something that writes a little thicker. Give me a sec. Here. They want to know what is the slope there. Okay, so let's figure out what the slope of that line is. And if I'm not mistaken, it's the rise over the run. So it looks like, and again, I can measure it anywhere. It looks like this is 40. And this is 10, so 40 divided by 10 is 4, and it is a negative slope, meters per minute squared. That is the slope of that line. Okay, same situation going on over here at 45, right here. I need to know what the slope of this is. I believe it is 40 over 15, which reduces to be 8/3 meters per minute squared. Okay, and then this last question, and it's not a trick question, but you have to remember that speed is absolute value. Okay, let me write that in. That is absolute value. Okay, so there's a couple different places where I have to find 40 meters per minute. That happens here because of that negative, and it happens here, not this one, because it's not in the interval. We're only looking from 10 to 50. So it happens at 20 minutes and at 40 minutes. Okay, let's move. Oh, that's not what I want to do. Let's move to this page, last page. Okay, and similar to the last one, this is the same graph actually. I would love to know if you could try these on your own before I tell you the answers. The graph that you are given is a velocity graph, right? It says so right here. It has a velocity graph, but yet I'm going to be asking you some questions about acceleration. So I'm going to start by filling in this chart for just velocity, Okay, I'm going to do this column first, okay, because that's easy to look at. It's easy to tell. Okay, so within these intervals from 0 to 10, that's here, that's above the x-axis, that's positive. And you can't see that, that's really light. There we go, that's positive. From 10 to 15, that's also above the x-axis. From 15 to 30 is above the x-axis. From 30 to 40, oh, now we're below the x-axis, that's negative. And from 40 to 55, below, that's negative, right? That's easy enough to see. But this column, the second one, this is looking at slopes, okay? Because it's acceleration. It's the rate of change of the velocity. So from 0 to 10, this, hold on. All right, so now I'm looking at from 0 to 10, that is not even visible. Let's try that again. 0 to 10. From here to here, that is a positive slope. From 10 to 15, that's this top part right here, that is a slope of 0. From 15 to 30, that's a negative slope. From 30 to 40 is also a negative slope. And from 40 to 55 is a positive slope. All right, so now let's see if we can answer these questions. When is this moving to the right? That's when the velocity is positive. So that's happening from 0 all the way to 30. And it's moving to the left when velocity is negative. That's from 30 to 55. A constant velocity is when there is no acceleration. That happens between, right here, 10 to 15. The particle is at rest. Now let me highlight these for you in case you're not seeing it. It's at rest here, here, and here. That's when the velocity is 0. So it's happening when t is 0, when t is 30, and when t is 55. All right, now these ones, increasing velocity and decreasing velocity, are talking about acceleration versus deceleration. In other words, where is there a positive slope versus a negative slope? Okay, so positive slopes for this top one, again, take a look at the table. We filled it in already. It's from 0 to 10 and 40 to 55 versus negative slopes, which happen from 15 all the way to 40. Okay, speeding up is going to be when in your table you have same signs, right? This is the same thing as that number line analysis we did earlier. It happens from 0 to 10 and 30 to 40. This is slowing down when it has different signs, which happens from 15 to 30, 40 to 55. The greatest speed, okay, keep in mind that's absolute value, happens here. So that happens in the interval from 10 to 15. And it changes direction when, and it has two different things that have to happen. The velocity has to equal 0. But it also has to change from positive to negative or negative to positive. Okay, so it's not just when the velocity equals 0. So it happens when t equals 30. All right, I know it's a long lesson, like half an hour. Thank you for listening.